Hello everybody, this is Gordon and we are starting the second set of problems with looking at density and specific gravity. The first problem, find the density and specific gravity of alpha alcohol if 80 cubic centimeters weighs 63.3 grams. We're going to use a relationship density is equal to mass divided by volume. And so putting that down, we have mass divided by volume. The mass is given as 63.3 grams. The volume, 80.0 cubic centimeters. Divide one into the other, and we have a density of ethyl alcohol of 0.791 grams per cubic centimeter. And since the density of water is 1 gram per cubic centimeter, we can say that 0.791 grams of alpha alcohol, which has a volume of 1 cubic centimeter. Since specific gravity is mass of an object divided by mass of an equal volume of water, the mass of 1 cubic centimeter of water is 1 gram of water, and so we come up with a specific gravity of 0.791. And the problem is solved. For the second problem, we're given the specific gravity of aluminum as 2.70. We're asked to find out how much will 20 cubic feet of aluminum weigh. Again, the specific gravity, 2.70, and we have the conversion factor, 62.4 pounds, being the same as 1 cubic foot. That'll give us a number of pounds, and then we have 20 cubic feet, which we're trying to find the mass, and that gives us 3,370 pounds. And the problem is done. The third problem, we're asked to find the volume in gallons of 400 pounds of cottonseed oil, which has a specific gravity of 0.926. We're given 1 gallon of water, has a weight of 8.34 pounds. So the density of water in terms of pounds per gallon is 8.34 pounds per gallon, and we need to find a volume. We have from our relationships over on the right hand side, volume is equal to mass divided by density. We know that the mass is 400 pounds, but we need to find the density of cottonseed oil. Well, we're given the specific gravity of 0.926. That's going to equal the density of cottonseed oil divided by the density of water. And we can rearrange that equation to say that specific gravity times the density of water will equal the density of cottonseed oil. That's just algebraic manipulation, rearranging the equation to solve it for density of cottonseed oil. Using the numbers that we're given, we have 0.926, the specific gravity, times 8.34 pounds per gallon, the density of water that we were given, gives us a value for the density of cottonseed oil, 7.72 pounds per gallon. And so now we can go back to our original equation and say the volume will be 400 pounds divided by 7.72 pounds per gallon. And run the numbers. We have the volume as 51.8 gallons. Our fourth problem is a question. Will a wooden block, which is 10 by 6 by 2 centimeters, that weighs 82 grams, float in water? What we need to do is determine the density of the block and compare it to the density of water. Density is mass divided by volume. We're given the mass is 82 grams. The volume is the height times the depth times the width. So that's 10 centimeters times 6.0 centimeters times 2.0 centimeters. And we come up with a volume or a value for the density of this wood as 0.68 grams per cubic centimeter. And so, since the density of the wood is less than the density of water, we can say with a high degree of certainty, yes, it will float. Our fifth problem is a good one. We're asked to calculate the weight of pure nitric acid per milliliter of concentrated acid, which assays at 69.8% by weight nitric acid, and it has a specific gravity of 1.42. Well, we know that 1 milliliter of the acid will weigh 1.42 grams. But that's only 69.8% of the acid. And so the number of grams of acid in that 1 milliliter will be 1.42 grams times the percent of acid, 0.698. And so the number of grams is going to be 0.991 grams. A follow-up question is, what is the weight of pure HNO3 or pure nitric acid in 60 milliliters of concentrated acid? We have the density from before as 0.999991 grams per ml. And so, since density is mass per volume, we can rearrange that algebraically to say mass is equal to density times volume. And we have mass of nitric acid equal to 0.991 grams per ml times 60 ml given. Multiplying those two numbers, we have an answer, 59.5 grams of HNO3. And we're done.